So we'll talk about a number of things today. We'll talk about some of the vShield pieces, some of our VXLAN pieces, and some of the way we work with physical gear today. Some of the trends we're seeing in the data center today is that as we go into, I spend a lot of time in the field with customers, with a lot of the folks that are adopting our products. One of the things we're seeing out there in the enterprise and also in the cloud service provider spaces is we do see some of these larger pods, larger L2s kind of coming about, and there's some trends that are driving that. Now, we're also seeing kind of, if you would, 10 years back, 8 years back, you might have had your 3-tier Cisco design, aggregation layer, core layer, access layer. Some of that's changing a little bit. So you have the Arista leaf and spine. You got some of the new designs with the Nexus line of switches and all that. So that also impacts virtualization, and so we'll talk about that a little bit too. Now, in some of our larger customers, we have seen where folks are taking L3 to the rack. And so if you specifically drill into that one, you might see that you might have some end of rows going into some aggregation switches, some top of racks, and that would be 3, 4, 5 racks, 10 racks could be your spanning tree domain, your layer 2, if you will. That's kind of the diameter, as large as your VLAN can span effectively. Now, one of the things we see in some of these customers, they will actually take a /24, take a subnet, or they'll take kind of an entire routed network into the rack. And in that particular case, every time you plug in a server, it's instantly on the network. But mobility is a little bit impacted when you go between multiple racks. So that's kind of the layer 3 that we see. We see that in our kind of larger accounts that are doing a lot of web services. Also, a lot of folks that are doing new apps that don't require layer 2, meaning that you're not using NetBIOS, you're not using some of the legacy protocols or clustering technologies that might be using layer 2 across racks. And some of the new trends we're seeing out there, whether you look at Nicira's technology we just acquired, whether you look at our VXLAN, whether you look at Microsoft's NVGRE approaches, or what Cisco's doing with VXLAN, folks are trying to get the layer 3 semantics, the benefits of layer 3 networking, but while still having the layer 2. So a lot of it is encapsulation, basically taking your L2 broadcast domains that are multicast capable, that are actually able to take care of all of the kind of broadcast traffic, if you will, but layer it on top of layer 3 and be able to stretch it across the data center. Now, we'll actually walk through why that makes sense in some cases, and where in a lot of cases it actually helps. We'll actually go ahead and explore where you would actually want to use the equal cost multipathing capabilities of VXLAN or other approaches, but then inside of that you actually get the full broadcast capabilities. And that really allows you to go across racks, across layer 2 pods, and still have your zoning be malleable, so you don't have to air gap in a very rigorous or kind of rigid fashion, if you will. And then the other thing we're seeing a lot is every customer of ours that's deploying kind of the larger cloud deployments, they've either went down the path of a vBlock-like structure, they bought a vBlock, worked with VCE, or they created their own. They basically created their own 3, 4 racks that might be doing compute, a few racks of storage, some end of row, kind of created their own vBlock kind of a structure. So we're seeing a lot of this high-density compute kind of fabrics being built out there. And that's where it looks like an opportunity to actually run some of your layer 4 through layer 7 workloads for networking. Not necessarily on dedicated hardware, if you will, but actually place it right on top of the x86 gear. And we'll look at some of the trends. We saw some of the trends out there. I've done 2 startup companies before VMware 4 years back, 10 years back, where we've actually gone ahead and contract manufactured boxes that would do L4 through L7. And some of the trends we'll see there is there's not a whole lot of hardware acceleration in that space. If you look at what a lot of folks do with layer 2 and layer 3, there's ASICs, there's fast forwarding engines, there's ternary cams for layer 2, and there's a lot of acceleration, and the hardware lends itself pretty nicely to the algorithms being used for layer 2 and layer 3. If you look at layer 4 through 7, you look at firewalling, you're dealing with TCP sessions, you're dealing with content inside of that. That's best done on x86, and what you do is you package up x86 on a contract manufactured system, front I/O, FRUs on the rear, and that becomes your firewall, that becomes some of your load balancing things. So we took a look at the upgrade cycle around servers, and one of the things we noticed actually is the upgrade cycle in the servers, and I'll get into that a little bit more, is really 12 to 24 months, maybe 3 years. So at any point you're running latest, greatest x86, and if you take a look at what your firewall might be running at that point in time, it might be 5-year-old Xeon. So what do you want to run your firewall on? And we'll go through some of those examples in more detail. And then we took a look at, can you take some of your network services and scale out like you're doing your compute, where you have algorithms like DRS with VMware and you have vMotion, things like that. Can we actually take benefits of some of these HA and FT kind of capabilities of vSphere and apply them to networking? We'll explore that in more detail as well. So what kind of forced VMware to embark on the networking track? I mean, as you can probably see, 4 years in a row, we're putting out new and more networking features, security features. One of the issues we have, why it really forced VMware to get into the space heavily, is we've gone down the path of just doing virtual machines, virtualization to begin with, and then we got the VM deployment down to fairly quickly. Most of our customers can deploy a virtual machine going through their, pretty much their remedy tickets or go through their request management cycle fairly quickly. But as you get into all of the things that VM might need, it might need capabilities around load balancer, firewall. Those things took some time, so you would see that remedy ticket go through 4 or 5 different teams, go through a bunch of different folks, exchange hands, maybe an outsourced firewall management team, and that might take actually quite a bit of time. So you got 2-3 minutes, maybe 1 hour to deploy some virtual machines, but to get the rest of the services, will the VLAN be available there? Will you have firewall rules there? We saw that take some additional time. So we thought, can we actually expedite that? And we did this by creating a set of canonical products, the vShield Edge, the vShield App, the VXLAN fabrics, but we also opened it up to our partners, our friends in Cisco, or F5, at Riverbed, and all the different companies, some of the best-of-breed vendors for a given technology out there, whether it's Layer 2 or Layer 3 or L4 through L7. We actually did everything that we were going to do, but we also allowed partners to plug in, so you as a customer have a choice which vendor you want to use. Now, this is kind of my poor way of depicting what the network might look like inside of a given fabric. So imagine that you have on the top set of servers there, you got 4 racks of servers, you got some storage there, and closer to me, you actually might have a set of fabrics that are running your NetScalers or your Cisco ASAs, your end-of-row services, if you will. So for every 4 or 5 racks, folks are standing up, and if you look at some of the examples of Terramark, how they've built their cloud, some of the earlier clouds being built out there, for every 3-4 racks of compute, you actually had a rack or 2 of networking gear. Some of it was end-of-row aggregation gear, high-throughput switch router, kind of a 6500 system from Cisco, for example. Or you also would have had a set of pizza boxes there that would have been doing load balancing, that would have been doing WAN optimization, things like that. Now, so when you start drawing the actual connectivity between the two, you would have been, I've been in a lot of these debugging customer calls where we're looking at what the data flow through the network is and things like that. And you might have virtual machines on the same host sharing the same hypervisor but in 2 different zones. And the path to the firewall, which is the end of row, is actually quite interesting. You would go first from one virtual machine to the virtual switch, then you go to the chassis switch, then you go to the top rack. From the top rack, you go to the end of row, then you get one arm to a firewall, then you come back down and you hit a VM on the same host but in a different zone. So we thought to ourselves, do we need this network U-turn? Do we need to go down the path of taking this U-turn through the fabric? Can we distribute out and actually get closer to the workload and then allow partners to plug in as well? And then we went down the path of actually trying to do a level of abstractions, and we looked at pretty much if you create your compute fabric and it could just scale out and then go ahead and actually start layering network virtualization on top of it. And then we decided, can we do the same air gaps you create today where you would have your couple of firewalls connected to a number of VLAN-backed switches that go to the top of racks, and that becomes your silo, your air gap for a given environment. Can we give you a virtual version of that, which is effectively what we do with the combination of vShield App, vShield Edge, and also the VXLAN devices. Now, we look at the services being attached not as much at the network perimeter or just in the interior. That is certainly how we deploy our products. We look at what the application might need when you deploy it. If you're deploying a multi-tier app and you got 2 zones and some of it, there's some pinholes that need to be poked between the zones from app side to the database side, and you need some load balancer VIP to connect inside. We look at things much from an application perspective versus actually going down the path of managing different elements. So if you look at some of our workflows this year, we're giving you very much a object-oriented way to manage the network, and we're spending less time managing IP addresses and things like that. Now, you've probably seen a lot of layers at VM where you see all these different products, how do they work together. One of the things we worked a lot this year is to try to integrate things. So we have things like App Director, working with vCloud Director. We focus things on applications. That would be, for example, the App Director. We have Cloud Director that spends time basically abstracting compute and networking and storage into different pools of use. And then we have kind of our vShield Manager and what we call the vCloud Networking Controller, which is basically the vShield Manager evolving into a networking and security controller at VMware. And so if you look at our stack, you have vCOps, you have vFabric applications, the Spring stuff. You have vCloud Connector to connect to other clouds. You have the vCloud APIs. In the middle, you have the vCloud networking and security layer. And we look at networking differently this year. We look at it as a way to actually connect multiple hypervisors. So one thing we find out there is you would have, one thing that's common across whether you run a physical machine or you run a hypervisor or you run a VMware stack or not, networking is the thing that connects all. And whether you have let's say a DMZ. In the DMZ, you might have physical machines, you might have virtual machines. Networking is one thing that's common to all of this. So we're trying to provide tools, and with the acquisition of Nicira, we're trying to actually provide, even going as far as working with the physical vendors to actually give you more granular control and elasticity across physical switches, across stacks that are non-VMware based, and also across our stack specifically. Now this is just a high-level slide on how we look at the world, how we look at a lot of our service provider customer and some of the early adopters of private cloud. And this is examples of folks that we've worked with, that I've been engaged with the customer accounts, where folks have built out a private cloud locally for self-service, for ability to deploy apps quickly, and then also ability to actually stand up all the networking they would need to do that. So one of the things you'll see when we talk about VXLAN, it's not yet another layer. It's actually a federation across multiple VDS, multiple switches, multiple top of racks, if you will. So if you look at how we've done networking before at VMware, we started out with pretty much a legacy vSwitch, as we call it now, the standard switch. And then it was on a per host basis. Then we went and realized that we need to make the management diameter larger. Let's align the virtual distributed switch with a cluster. Then we went and took it across multiple clusters that map to your layer 2 broadcast domain, to your spanning tree domain, across multiple racks in a given pod. And what we classify as a pod, and what different customers might call it different things, it would be a set of racks that have top of rack or end of row gear that all can participate in the same broadcast domain, same VLAN set. And so that was capable by VDS, and we have numbers such as 500 hosts per VDS. We can span quite a number of racks. But that wasn't enough, because we got into some large compute environments, and what happened there was that folks would start placing their workloads, Cloud Director and just people using vSphere, vCenter directly would start placing the workloads and start filling up those 4 or 5 racks that actually sit in the layer 2 diameter. And then they run out of space and they go to the next pod. But guess what? That same DMZ zone or that same particular VLAN is not available there. And you're going across a routed core. So it's not very easy to actually stretch that LAN across. You have to basically create a separate silo, separate perimeter firewall set. And so we said that doesn't quite make sense. Can we help? And so we worked with Cisco very closely on the VXLAN approach, and we actually have a layer 2 encapsulation capability that will actually take it over UDP over layer 3. And what you can do now is you can actually create the same zone across multiple virtual distributor switches. You're creating effectively a VXLAN fabric, which looks like one large switching fabric in the data center. And you can actually carve up the entire data center and create virtual wires that actually go across clusters, across racks, and across pods. That means that in our Cloud Director, where we have a placement engine that does the checking of is compute available, is memory available, is storage available, it now does another check. It does actually a networking check as well. And what we used to do before is when we used VLANs or when we used our vCloud network isolation in VCDNI, we only had the diameter of that single pod. So you would actually start placing workloads. Cloud Director says, yes, in this particular rack, compute's available, rack unit 4, there's capacity there, go ahead and place a virtual machine there. Then we do a networking check and we say, oh shoot, VLAN's not there. We actually can't place the workload there. Forget it, we got to go to a different cluster. Now, simply the networking diameter aligns to the compute diameter. We actually, when the compute engine says that we want to do a DRS placement of a virtual machine in this particular cluster, the VXLAN fabric stretches, and the virtual wire that was available in cluster 1 is now available in cluster N. And it stretches, and it's available there, and it goes behind the same load balancers, same perimeter firewalls. And using this VXLAN technology, we can also extend the reach of your layer 4 to layer 7 boxes, whether it's the vShield Edge, which is virtualized, or the F5 virtualized system, or a physical system sitting in a rack A, and you're trying to get the VXLAN to rack Z. That's now possible without having any kind of OTV or VPLS or various kind of more complex approaches to stretch layer 2 in the data center. Now, one thing I didn't quite mention, I showed it in my demo during the keynote, but we now have a capability to actually stretch networks into the cloud. Now, layer 2 stretching has certain merits and has certain problems with it. So one of the things that people really like about our capabilities, about being able to extend layer 2 between 2 different administrative domains, like a public service provider in your internal network, is that you can take some workloads, especially dev test or some of the ones you need to scale out very quickly, put them on a public service provider cloud of your choice, use our vCloud connector product, plus the vShield Edge integration that product has, and be able to extend the layer 2 into the cloud. When you move your virtual machines there, no IP address changes, your netcools, your OpenViews, your Nagios, none of these tools change. They still monitor the same machine. VCOps monitors it, and the load balancer config and the firewall config doesn't change. And all the broadcast unknown DA flooding, multicast, that can actually go traverse that layer 2 network as if it's local. But it has a little bit higher latency, does go across the internet, and we do have encryption there. We do use our SSL VPN. the acquisition that we had basically a year plus back of NeoXL, that's now integrated into vShield Edge, and we use that to actually do both user-based VPN, and we also use a stretched layer 2 networks. It appears to be web connection, appears to be SSL, and it actually has encryption, and it does leverage some of the hardware offloads for some of these capabilities. And that connection between the interior VDC inside this silo, the virtual silo you create with the Edge, and the VXLAN networks, you can now extend it out to the cloud. That's something we can do today, shipping out there. Just wanted to share a little bit more how we view the world. So in certain in service provider accounts, we got multi-tenancy notions. That's a little bit earlier and just getting started in the enterprise. In the service providers, we have been running the vShield Edge. We've been running some of the VCDNI and VLAN-based cloud networks, network pools and cloud director for about 2 years. We have about 2 years worth of live operational experience out there. Did a lot of product tuning. And as you know, some of the service provider customers have the toughest environments. If you can make it work there, you can make it work pretty much in a lot of the enterprise cases. But then when you get into some of the customers like yourselves, the enterprise, you have a lot of operational workflows, a lot of tying into some of the change management systems. So our team has had the privilege of having about 4 years experience of actually doing the virtual appliances and actually working with VMware customers, getting it out there. And the way we look at the layers is you can have a self-service tenant layer and you can have a provider layer. On the tenant side, we look at tenants in the service provider space as you're getting a context. You're getting a kind of shared cloud infrastructure, and you're carving out a single context to run your broadcast domains, your zones, your virtual machines, your perimeter devices, your interior security devices. In the enterprise side, it could look like a line of business or interior silos. So whether you're going to, I look at some of our customers that are in the financial sector or on the, running a more smaller commercial size kind of deployments, folks create these air gap silos, and they're trying to move to either consolidated environment and try to put multiple zones on the same set of hardware to be able to use it more efficiently. When I start trying to understand why folks are trying to do that, it really came down to the fact that you have pockets of compute that are basically all separate, that are sitting in different zones, different air gaps, and some are overutilized, some are underutilized, some have extra capacity. And what we're trying to do with these virtual silos with pretty much our provider side of APIs, is we're trying to give you a really excellent way to carve up that compute to be able to load it more and actually reduce the cost on how much hardware you need to run and to how many air gaps you need to create. So if you take a look at our controller, if you look at the way software-defined networking is evolving to these days, it's not so much about every single data plane piece. I mean, data plane's important. Our virtual distributed switch is important. Our data path in the ESX from VNIC to PNIC in the I/O chains and the DV filter, that's all relevant and important. And if it's a Nexus 1000V you're choosing, that's an important element. It's now becoming about more of the controller. As you saw with the Nicira acquisition, as you saw of our evolution of vShield Manager being the integration point for partners and being also the controller for the Cloud Director networking stack, it's becoming more about the controller. It's about central management. It's about being able to reach out wide and be able to program things to the REST APIs. In fact, I see a lot of some of the newer networking engineers, folks that are evolving, the virtual network engineers are becoming kind of mixing the world with DevOps. So there's a lot of programming. Before it might have been Perl expect, logging into CLI. Now it's netconf or REST APIs and things like that. So that's where things are evolving. Now, from that perspective, you don't want to be in the business of managing hundreds of devices across the network. You want a controller or set of controllers that can give you that capability. And in some ways, the firewall market has been a little bit more advanced than some of the switching market. If you look at central management for firewalls, there's great products out there like Checkpoint Provider One. There's products from Cisco like Cisco CSM. But we've just not had that for a lot of the layer 2 and layer 3 pieces if you want to manage the entire data center. And if you look at what we're trying to do with the vShield Manager, which is now becoming the vCloud Network and Security Controller, if you look at what Nicira folks have done, these controllers are basically the API entry points. That's where you come in with all the DevOps and the new virtual network engineering scripts, and you can stand things up on the fly. And I'll walk you through how we do our VMworld labs and how we do a lot of our internal engineering work at VMware, because if every single engineer in our team had to get a set of firewalls and routers and boxes to do their testing or to do their development, we'll be here for years. We're able to deploy complete environments with virtualized networking security stacks on the fly. I'll go through that in more detail. So in order for us to basically enable some of the vision of the controller and different management of different data plane components, in our vCloud Networking Security Controller, ultimately we provide the self-service APIs where you can come in and create your own perimeter services and your own interior services for networking, also your VXLANs. Those are all self-serviceable, but to make that happen on the provider side, there are a number of stacks. We have our network virtualization stack in the vShield Manager, in the vCloud Networking Security Controller that takes care of a lot of the VXLAN pieces. We have the edge virtualization stack, and that is our virtual end of row, if you will. So whatever you would put at your end of row or the DMZ of the enterprise, we're trying to virtualize that, and we provide the APIs for other folks to plug into for that front. And then we have our NetSec Virtualization. That is actually a combination of, can we take a firewall? Can we, before doing all this choke pointing and U-turning, can we actually put a firewall, like we did the distributor virtual switch, can we put a firewall on every VNIC, every virtual machine? And what we do with vShield app, we actually basically give you a single monolithic firewall view for entire data center, but it's a firewall that has high port density that plugs into, every server plugs into effectively. So that's the best way to think about that product, and I can talk through that in more detail. And across different layers as we have here, starting from vSphere, going into vSwitch networking, going into the VNIC and the PNICs and the teaming layers as we have there, the network I/O control, getting into our network insertion where we actually allow partners to do traffic steering. You have all the set of APIs. So one directive we have from our management team is that anything you provide in the UI, you have to put in the API. So for the first time, you have pretty much parity between what you can do through the SDKs and APIs and what you can do with the UI. And you don't have to think as much, or is it there? Do I go through the CLI? Do I go to the API? Do I go to the SDK? Do I go to the GUI? In our case, it's actually parity. Now this is a drill down view into the vShield Manager, into our vCloud Networking Security Controller. So on top, there are different products, whether it's vCloud Connector, whether it's App Director, whether it's going to be View coming up, whether it's App Director this year. We actually provide a set of integration through the vCloud Networking Security APIs in the company and outside the company. So the way our products integrate inside is using the same REST APIs as we provide to the customer. If you want to create your own portal, if you want to tie it into, we even have customers doing things like running SharePoint, creating networking workflows when you deploy an app. So we've seen pretty much anything from HP Orchestrator to SharePoint to other custom tools. They're actually creating things on these REST APIs. And that's the same way that the App Director, same way that the vCloud Director and these other products actually integrate with us as well. And having that layer is right on top of the what we call our Networking and Security Controller, which has all the different stacks. It has our network insertion, so we're working with our friends at Cisco and F5. You've seen our first network insertion happen last year when Cloud Director customers that wanted to use Nexus 1000V asked for. We've been going to the Cisco CLI into the virtual supervisor module and punching and creating the networks. But we want to have the same network pooling capabilities that VMware has. We want to be able to, like we do in the VDS, use network pools, automatically create networks. So when somebody wants a network broadcast domain zone, it happens on the fly without punching CLIs and going through 3 different boxes to do it. And we've done this with our vCloud Networking Security Controller, vShield Manager, calling out to the Nexus 1000V APIs, creating these networks on the fly. That was last year. This year, we're bringing more we actually have more folks like the F5, like the Riverbeds we're working with, and they're using the same set of APIs, plugging in, and you can actually have the vCloud Director self-service portal for, let's say, F5 load balancer. It's either controlling our edge or it's controlling a load balancer. When you delegate this to your app users that want to configure a VIP, configure pool members, configure health checks, use some of the IAPs, that is something that will be possible. And it's the same workflow whether you use different vendors, but different vendors can actually come in and provide their value add by actually exposing templates. And you have role-based access control around that. You can delegate it, and there's no need to retrain, whether it's a different vendor. If they're using the VMware stack, it's going to be the same experience for your customers that are using the delegated service. Now, below some of the other pieces, we have the VXLAN, we have the vShield Edge management, we have the vShield app management for the firewalling, for the routing, for some of the load balancing and VPN capabilities. We also have the third-party extensions, and that ultimately is going to talk to either a third-party manager, whether it's a F5 manager or a Cisco manager, or it's going to talk directly to the devices themselves. So in our cases, it'll talk directly to our data plane, and it'll go down and talk to the partner. And in the virtual switch layer, we have things like traffic filter. Basically, if you used the Cisco or Juniper before and you've tried to plug in, let's say, a Riverbed box, you would have been doing WCCP, you would have been doing policy-based routing, you would have been doing on a Juniper filter-based forwarding. There's different approaches. What these techniques are is traffic steering. It's ability to take and create exception forwarding paths through the fabric to get L4 through L7 in or to get a web proxy in. So we have the same capabilities this year in the VDS. You got basically traffic steering in the hypervisor, API-driven. This could be controlled by the customer. It can be also controlled by the vendor. And you can actually deploy as a service IPS IDS, or deploy as a service a load balancer ADC. And not only do you consume the management plane, the UIs are available to control these systems, you also have the traffic steering capabilities to get traffic to these systems, whether it's a physical system, one-armed on a VLAN, or it's in the forwarding path inline, or it's getting redirected with a tunnel. Those are all the capabilities that we'll actually show you. And for each layer, we basically provide a set of APIs. So if you look at on top, you might have vCloud Direct or vCloud API. vCloud API is rolled up, simplified for self-service, and there's some service provider or IT as a service workflows there. But primarily, that's our tenant-facing API, and it's uniform across different service providers that we have. Now that becomes interesting because when you have a lot of the same API available across vendors of your choice, when you write your code towards a vCloud API to place VMs, to bring them up in a different VDC, that code could be reused and shared across different service providers and allows you to have a choice of plugging into a different service provider fairly quickly. On the next layer, we have more of the provider-side APIs where you actually create the virtual network engineering type of things, where you create your VXLAN fabric, you create your diameter of the layer 2s, you create your VXLAN segment IDs, you create your edge devices that are going to be serving up some of the perimeter services, if you will. And then lower than that, we have more of the partner APIs where they plug into the stack, where they get traffic steering, they get to expose their templates. So that's kind of the layers of the APIs that we have. Just wanted to draw out some of the simple topologies that we allow to create today with some of the new SPOC, and as we call 5.1, our internal names are T2 SPOC for these releases, Cloud Director 2.0, Cloud Director 5.1, and also vShield 5.1 and vSphere 5.1. So here we have your typical virtual silo, how you can create something like this on compute. Imagine you have 3-4 compute racks. You want to carve them up into 4 or 5 different virtual air gaps. This is the topology you can create. You can create a kind of perimeter with a VXLAN network with a couple of large edge devices. Let's say you were looking for 10 gig throughput. You're looking to get maybe 500 to 1,000 firewall rules. You want to be able to handle up to 500,000 to 1 million concurrent connections. Fairly decent sized environment. So we'll actually put 2 vShield edge devices at the perimeter programmatically or through our UI workflows. Then we'll go ahead and create the VXLAN virtual wires inside. And in this particular case, we may want 2 virtual wires. We may want to go ahead and actually have a perimeter app that's going to be sitting on the DMZ that has a web zone and the DB zone. We might have some internal desktop sitting on a different VXLAN. And for the perimeter zone, for the ones that are sitting in the DMZ, we also want a set of load balancing and firewalling capabilities. So we can have different sets of hierarchies here with static routing and with also capabilities to actually do basic routing between subnets and things like that. And what we can do here is not only do we do multiple VXLAN to give you the subnet zone capabilities. If you look at when I go out to customer sites and I kind of go into the DMZ environment, I might see 10, 15, 30 different networks. A lot of these will be /26s, /25s. I kind of call it a tiny VLAN problem. The problem ends up happening is you want to segment your apps and you want to have very tight kind of a perimeter around them. And the app would be fairly small, maybe 10, 15 machines, 20 machines. So you don't want to go down the path of giving it a /24 or a large block, but at the same time you're creating the VLAN because you're choke pointing between zones through a firewall. So you pretty much have these small VLANs. So one of the things we thought, well, we have a point of enforcement in the virtual stack at the VNIC. Why not have a larger, when you're consolidating your DMZs, create a larger VXLAN-backed network? Maybe it has 100 hosts or 200 hosts or 800 hosts. We actually have some prescriptive guidelines on how much you can go without getting into signal-to-noise ratio getting high with the ARPs and the multicast and things like that. You can build a fairly large VXLAN-based network, and then you can use our vShield app to do microsegmentation. So you're not creating VLANs with choke-pointed firewall forwarding path for creating zones. You're basically using rules that look like business language from this zone to this zone, from this set of machines based on their resource pool or based on their folder to this particular set of virtual machines. And you create that, you microsegment that VXLAN network very granularly. And we have Ethernet level firewalling where you can say to the default gateway you can go IPv4 and ARP, but then between these virtual machines allow just pinholes to work. Let's say a DB going towards Oracle 1521, talking from the TC servers, so allow that pinhole to go through. And you don't have to actually create a lot of subnets and a lot of VLANs to accomplish that case again. So actually your network infrastructure, your topology becomes a little bit simpler, and you can visualize the firewall rules. Imagine if you're doing PVLANs, you can do PVLANs with firewall rules without the complexity of managing the community VLAN or promiscuous VLAN, things like that. And so we've micro-segmented our web zone in this particular case. We said that web servers really never have a reason to talk to each other. If somebody owns one web server, they should not be able to use it as a bastion host and start attacking other web servers. But then we allowed a pinhole to go to the database side on port 1521, and the web servers are opened up towards the default gateway, towards the exiting the VDC. And then we uplink these vShield edge devices to the core network that might be facing towards the internet eventually. It might be going towards the MPLS VPNs if you have a provider of your choice. Now, this topology is pretty much what a lot of our cloud service providers do for the VDCs that they create for our tenants. But also in the enterprise case, this could be something, an interior silo. It looks actually fairly similar from that perspective. And our service insertion, when you want to go into this virtual data center, if you want to introduce another application delivery controller, you want to introduce another IPS IDS that might be physical, we give you those capabilities with insertion. So we actually allow you to plumb in all your services. It doesn't have to be VMware services. We would just like for you to use our products, but ultimately you can work with partner of your choice. It is an ecosystem-based company, as you can see by all the partners in the expo. Plug in all the appliances of your choice, and it all works together using our self-service APIs, or you can use the GUIs and the centrally managed consoles of your vendor of your choice, but the data plane goes to them because of our traffic insertion APIs. Example of how we do our VMworld labs, and also not just the labs, but the way we do vForums and a lot of different other kind of labs as a service, if you will. So we actually had some interesting issues this year, and I kind of look at why we built VXLAN and why we built the edge and some of those things. And some of the issues we had in the labs, I was involved debugging some of these things. Sometimes you have subnets missing from firewall rules. You're missing a given container. We were missing some VLANs off of UCS system and things like that. And when we look back, where we can use, we're actually using VXLAN as much as possible. But as we interface with the physical world, until the Ciscos of the world and Arista is actually doing this now, a VXLAN capable switch. And as Cisco gets into having their physical switches doing the VXLAN as well, then it actually could extend their reach. So some of the problems we actually had, VLAN-based, subnets missing off of firewall rules, could be avoided. So the way we run the labs is somebody could bring your own device common environment. You've probably seen these coffee shops and little scenarios we had in the labs, if you've seen the labs yet. And we use a Horizon portal to basically plumb in your user ID, because we're going to need that later to actually make it available in the labs in your Active Directory controller that's running your particular lab. We actually go ahead and entitle you to have a lab. So you come in, you get redirected to a portal running in our SwitchNAP data center in Las Vegas. You have a McDonald's menu of the number of labs and which ones you want to take. Once you take the lab, we actually spin up in a cloud API. We use kind of VCD inside SwitchNAP, but we could also use it with a partner of our choice, a service provider running vCloud. And we stand up a organizational VDC for labs. This is going to be shared VDC used by many of our folks that are going to be sitting down taking the labs, and we're going to slice up the compute, the networking, the storage available here. Then we'll actually create, once we got the virtual data center, we deploy a set of large edge devices, because we got everything, all the view environment that's used for labs, plus the BYOD is actually traversing to the same edge devices. So that gets set up in the perimeter first. Then we go ahead and create a shared org network that's going to be VXLAN backed. That's going to be pretty much the broadcast domain that's used to uplink all the different labs to. Once we've done that part, we'll actually start deploying the labs. Now, each individual lab is pretty much, think of it as a ship in a bottle. It basically is a vApp inside a Cloud Director on the outer Cloud Director, but inside it runs Virtual ESX, inside it runs Virtual Center, vShield Manager, vCloud Director, SRM, whatever lab you're taking. And it also has Active Directory server. And the Active Directory server runs a proprietary, kind of a new, not yet released version of View client, which allows us to connect PCR IP clients directly without security gateway right through the vShield Edge device with programmable firewall rules right into the Active Directory server natively. So once you stand up the lab, next thing we'll do is we'll create a topology that could mimic a small enterprise network. You have your FT network, you have your vMotion network, you have your storage backend network, you have your VM data plane network. Once you've created this topology, then we actually start placing our workloads, which are virtual ESXs that have kind of a layer of inception, if you will, different set of VMs inside of that as well. And that stood up from a single vApp. As soon as that comes up, we'll actually go ahead and programmatically come in through the REST APIs and program the firewall rules to enable the pinhole for 4172 TCP UDP for PCR IP. We'll punch in RDP through that. We'll also punch in 443 for View to talk through it. And then you have actually a programmable kind of stood up app. As soon as you're done with the lab, it goes away, gets deleted. Those firewall rules go away as well. New customer comes in, one of you comes in, sits down, gets the entire lab. And we've done this for about 3 years now. Now, the way we build these labs, too, is we pretty much take our beta code and we'll put it into these labs, and we try to stand up VMworld on that. And we basically try to make it work. By the time it goes GA, you get something that's very solid, and you actually effectively help test the system and help participate in getting the product better and better. Now, this deploys vApps. On average, we're seeing deployments every 1 minute of a complex vApp like this. And if you think we're running an environment, 8,000, 10,000, 12,000 VMs, you would think there's hundreds of racks running this environment. We're really talking about 3 data centers and a few racks per data center with high-density compute that's running the entire VMworld. Now, just talk about the air gaps, talking about network topology. So on the left-hand side, myself coming from network engineering background, the picture I see on the left is fairly familiar, and I'm comfortable with this picture. But the vSphere admin sees a picture like this on the ESX host. So if you have multiple zones on the same ESX server, it kind of looks like each individual color palette here is actually a separate VLAN plumbed into virtual ESX. And this shows the forwarding path through the firewall, back down between the VMs, terminated at the firewall, how you go between different zones. So for us networking folks, this is fairly simple and straightforward. But for vSphere admin, looking at a single set of ESX hosts, you got to kind of have this puzzle of, and so we thought, why do these U-turns? Let's go ahead and actually terminate and try to distribute out the firewalling and some of the security pieces on the ESX as well. Now, those solutions are available. vShield app is one, but Juniper has a great solution out there. Cisco has also the VSG, which is a solution that does something similar to this. So we'll talk through that more in detail. So now talking about specific point products, if you look at our Edge Gateway, we wanted to provide a virtualized kind of appliance that gives you some of the basics, some of the main required features you would need to do at the perimeter. So some of the things we see in a public cloud environment in the service provider space, you need fairly high throughput VPN. We have customers that are running hundreds of megs of VPN throughput per tenant kind of things. You also need to have a user VPN for SSL VPN connectivity for the rogue warrior case, somebody sitting and trying to manage a remote data center. We also provide firewalling capabilities. And if you talk about a firewall, it's not as simple as putting a firewall engine in. The firewall engine is just a start. It's all the management. It's the rule table. It's the object-oriented inline editing that goes along with good firewall management systems. It's all of the how many objects you can scale to, how many rules you can scale to. And one of the things we found out there, if you look at every single vendor trying to do virtual firewalls, they went down the path of trying to recreate the wheel. Most of the world's very comfortable with a Cisco ASA or Checkpoint kind of a management model. Juniper SRX, very happy with those products. When the firewall vendors came in to try to do the virtual approach, they completely decided to do something different. Let's change the interfaces. Let's create something altogether different. One of the largest feedbacks that we had from our customers that have deployed us at scale is we have outsourced operational teams running these firewalls. We have a bunch of enforcement points. We want similarity, and we want a single firewall UI, central management console, but we want to be able to manage it on a per ESX basis and be able to use the same look and feel that we're used to. So if you look at our product this year, some of the inline editing, some of the stats available on the per rule basis, multiple containers, the advanced containers we support. Most customers that have been running firewalls for 5-10 years would be very comfortable with the system we've actually exposed this year. So just wanted to give you some performance numbers. So this is the year where the virtual appliances grew up. This is the year where you're actually getting very high throughput and you're getting some actually really nice number of contexts in a single rack. And what we're seeing here is not only the optimizations that we're having in the vShield product line, in the VMware networking stack, but it's just the Moore's Law. You can pretty much deploy a vShield Edge appliance from a year back, and it'll go faster no matter what you do as long as you upgrade your servers. You put the Sandy Bridge out there, you go to Ivy Bridge, you go to the latest and greatest hardware, it's going to go faster. And so that's kind of unheard of before because you forklift your servers much quicker than your networking gear, and your networking gear might be on this contract manufacturing cycle of 5 to 7 years. As you upgrade the boxes, they actually just accelerate on their own. So just to give you some numbers, we talk about performance on the management plane, and we talk about performance on the data plane. On the management plane, in the cloud environments, we deploy quite a bit of these vShield Edge devices. So we have customers, some service providers that I'll log into. It's not uncommon for me to log into a VC environment and see that they ran out of ephemeral port groups because they got so many edges deployed and they got so many contexts running out there, and they're actually out of ephemeral port groups, and we're switching folks onto the actually static and elastic kind of port groups that we have now. So that's the kind of densities we're seeing out there that force us to actually be able to support 2,000 vShield Edge devices per vShield manager, per vCloud networking controller. In an HA mode, it's actually 1,000 pairs that we can do. We also can support 5,000 VXLAN networks on a single vCloud networking security controller, and you can scale out the controllers, and as you have multiple VCs, multiple vShield managers, you can get to more numbers than that. On average, a fully configured with hundreds of rules, with VPN tunnels, with load balancer configurations, you can template and deploy an edge over and over again. It takes about 3 minutes to actually get it deployed on average hardware. We're not talking about Sandy Bridge or something new. We're talking about Westmere. You can actually get a full edge deployed, fully up and running from a REST API template in about 3 minutes. That's the VM deployment cycle. That's the connectivity between the ports. That's the appliance configuration. We also tested our controller. If you manage a large firewall environment, you'll see that it's not about rule sprawl. It's about the object sprawl. And the objects are as you create a new server or you create a new virtual machine and you need to create an object for it and reference it in a rule, that's where the sprawl happens. So we've tested up to 130,000 firewall objects per single controller, and the individual devices can do 4,000 firewall on that. The latter is more of a soft limit, but that's what we've seen out there, and that's what we support. As far as throughput, this is a software stack. It does different things at 64 bytes versus what it does at 512 bytes versus what it does at 1,500 bytes. To share some of our forwarding numbers for 1,500 bytes, the edge that has 2 vCPUs and about 2 gigs of memory can actually give you roughly a little bit under 10 gigs of throughput with TCP traffic, with multiple firewall rules configured, with real TCP flow throughput. We measure this with Ixia. There will be a report coming out with all the details. Now, if you get to hundreds of rules and you get down to the actual, having mixed traffic, the kind of the trimodal internet distribution of traffic, you might be seeing more 5 to 6 gig, 7 gig kind of a throughput. That's something you should expect out there. This device also scales up to 1 million concurrent connections at a ramp rate of 50,000 per second. So we actually, with this is a pretty reasonable capability at this point, we're able to actually create DMZs that have multiple parallel edges deployed, and that's not an unreasonable way to get a very high number of concurrent connections. Now, on the load balancing side, we get to roughly between 6 gig, 6.5 gig or so at the same rate as the firewall. So our firewall numbers are roughly the same as our load balancer number for layer 4. Layer 7, when we're doing some of the URI and some of the rewrites and some of the layer 7 pieces, we go down a little bit more to more of 3 gig kind of throughput, 400,000 concurrent connections. And on the IPsec side, the IPsec is the first area where you see Intel and VMware working together to actually provide hardware acceleration. So IPsec on vShield Edge is hardware accelerated. So before when you create a firewall, you would go to a contract manufacturer, lay out your board, plug in your SafeNet or your KVM devices to do crypto offload. Well, Intel gave us that capability on every server out in the data center with AS&I. So we're getting 2 gig throughput for IPsec AS256 traffic on a single edge device. So we start looking at how do you make these boxes. So if you open up a firewall device out there, you take your pizza box, look inside, you might open up your desktop and you might see a very similar processor from 4 years back running in this device. So we thought to ourselves, why not basically, do you want to run it on this kind of a platform? Or do you want to run it on this kind of a platform? Or the Cisco UCS, where you might have the B230 blades, some of the fastest and the latest processors available, refreshing every 2 years, every 3 years. And as you upgrade that gear, your actual x86 and that's powering your firewall and your networking features goes faster. So we ran some numbers. So this is the rack that we run VMworld on. In this particular case, we have 2 setups. We have UCS and we also have the Super Micro Rack. Super Micro Rack, we actually get to this kind of compute density. 120 servers per rack. It's a little bit challenging to do the cooling, but we do it. And then we have 16-way Sandy Bridge blades, not the fastest processor, but pretty fast. And then each server has 2 10 gig uplinks, and we got a combination of Cisco and Arista for the top of rack switches, and the chassis switches are the Supermicro switches. And so the kind of numbers we try to do here as we place our vShield Edge devices in these notions of network clusters, we're actually able to get to a very large number of contexts. So if you take number 42 RU, how many contexts can you squeeze in for a VPN, for firewall? You start comparing to some of the largest firewall boxes out there, and this is the first year it's actually reasonable to get to 480 to 960 contexts on a per rack basis. That's more of a service provider use case. We don't have too many enterprises that are requiring this many contexts. But there's 2 ways to run the system. You can take this and run in a single rack, network cluster, for a given pod, or you can go down the path of mixing the edge devices with your workstation, with your VM workloads, because that's something that's possible from the DRS perspective. And if you look at resource isolation inside of the ESX, there's a lot of innovation that's happened over the last 7-8 years as far as how do we split up workloads from each other. There's no platform in the world that can do as good of a job as splitting up the resources. So if you look at contextualized system, your firewall that has multiple contexts, It's not going to have the same level of resource capabilities to ensure that one customer doesn't overrun another like the vSphere stack does. So this is not an unreasonable way to get to numbers like 500 million concurrent connections. We're working with large customers now that have DMZ requirements. They would have required a large cluster of pretty big firewall boxes. Instead, you can go down the path of creating a cluster like this, add virtual devices either from Cisco ASA1000V, or vShield Edge. There are different approaches going to be available out there. And this is not an unreasonable way to get to very large context, high throughput kind of environment. vShield App Firewall. So VMware has 2 firewalls, and people ask us why. Well, if you looked at the enterprise 10 years ago, you might have had crunchy shell outside, some perimeter firewalls. You trusted everyone inside. World was a fairly safe place in the 90s. Come in here, and now you have very hard lines around VMs inside, silos, air gaps. That's changed in the last 10, 12 years. And so from that perspective, we give you micro-segmented kind of capabilities inside of the networks. So it's imagine a host-based firewall running on every VM, but without any agents. It allows you to control exactly at the front door of the virtual machine, and that's your east-west traffic, if you will. The north-south is handled by the perimeter firewall, your edge device. So what you can do in these VDC notions, on the top we show the vShield Edge protecting the perimeter, providing the load balancing, the VPN, the filtering capabilities. On the inside, we micro-segment it into different containers, different zones, and that's how we actually carve up inside the VDC. Just wanted to share a few screens from the product, and then we could take some questions, or we can have a group discussion. The last time I did a session, we had a bunch of folks come up and ask questions. This is pretty much the new firewall table that we delivered this year. So you can see what used to take maybe 20, 30 rules before takes a single rule, because we give you the complete object management capabilities. You basically have in a single rule, you can put multiple containers per source. Now, the richness of the containers that we have, you see we're using vCenter containers. You can use clusters, you can use resource pools, you can negate objects, and you can use VMs, or you can go down the legacy objects, which would be the subnets, the IP nodes, the CIDR blocks, and the kind of ranges, if you will. Those are all visualized. And then we have a rich set of services available in the firewall, so you can pick the vSphere apps or the Tier 1 apps that might be running on there. This UI was driven around how can we quickly create 30, 40 rules, somebody punching it in very quickly, without having to think about IP addresses. So that's where we went down the path of inline editing, dynamic containers, and be able to view traffic stats on a per rule basis to see if there's activity. And then more importantly is how do we tie this into your operational processes? So if you had a remedy ticket, put into the notes field. If you want the rules to be readable, what the purpose was, there's a comment field. Those seem like relatively simple things, but without operational tie-in, without being able to give folks a familiar interface, it just doesn't work to roll out these firewalls. We also provided a capability, if you look at our NAT table, so our firewall table would look familiar to a lot of the network and security folks. Our NAT table, also, we've not tried to reinvent the wheel on that. It looks also very similar to some of the other devices you would see. Once again, it's not about doing something altogether different. It's about tying into the existing operational practices by providing the scale-out firewall capability. We also provide a lot of statistics in our UIs around the vShield Edge and app devices. So you need to make a decision that when are you hitting the ceiling of the number of resources given to the device, how many concurrent connections, how much throughput on a per interface basis, what's the connection ramp rate for load balancer for the firewall, so you can make a decision. Do you upgrade? Do you go scale out? Do you upgrade your hardware? Do you go to a larger edge device? So we try to provide this information at the fingertips. We also provide on the vShield Edge, it used to be more of a traditional firewall, uplink, downlink, inside, outside. At this point, we actually support multiple interfaces. You can have multiple zones, route between the zones. And we're actually going to be looking to even scale that up next year, more than just 10 interfaces like we have today. Load balancing, we went down the path of providing, we work very closely with F5s, with Riverbits, with their Stingray product line. We also work with the Cisco folks. And you have, for example, from F5, you got the I rules, you got some of the IApps, you got some of the advanced capabilities. What we provide in the vShield Edge is some of the most common use cases. You might need to do certain persistence options. You might need to have different pools on health checks and be able to pass through TCP and SSL. And that's some of the capabilities we provided this year. We actually advanced our load balancing capability significantly, and you can take a look at that. That's roughly all the content I had. At this point, if folks want to have a discussion, I'll be up here for about 10 minutes. Any questions, we'd be happy to go over it. Thank you.